Hi friends, hope you are doing great. Today we are going to see this demo. We are going to see this real-time weather data pipeline on Google Cloud Platform. We are going to use this Cloud Composer and BigQuery and GCS automations. We are going to use it, friends. Okay. So this is the real-time weather data pipeline, right? So we are going to fetch the Open-Meteo Weather API. We are going to fetch the data from this API, and we are going to load the data into this Google BigQuery by using this Cloud Composer tag, friends. Okay. So these are the steps which we are going to cover it, friends. So we are going to build a fully automated. We are going to build a fully automated real-time weather data pipeline on Google Cloud Platform. So here, basically, we are going to use this Cloud Composer or Airflow to schedule the workflow. Okay. So first step, we are going to fetching the data from the Open-Meteo API. Then we are going to store the JSON into the Google Cloud Storage. And third, we are going to load the data into the Google BigQuery. We are going to it will be running the automatically every hour. Okay. Then auto creates the bucket and tables. No manual setup required. Okay. So these are the steps which we are going to cover it today. Okay. So fully we are going to use the code only, friends. So before entering into that demo, just we are going to see what is the cloud composer, why we are using it, what is the purpose, what is the advantage with it, so friends. Okay. So what is a cloud composer? Basically, this cloud composer is a Goo- Google's cloud fully managed workflow orchestration service. Okay, which is built on the Apache Airflow. It lets we can schedule, automate, and manage complex workflows across GCP and external systems. So no need to manage the Airflow infrastructure yourself, friends. Okay, so cloud Google they will be taking care of that. Okay, so simple terms I could say cloud composer that is managed Apache Airflow on Google Cloud. So we need to write the workflows as a Python tags. DAX is nothing but direct acyclic graphs. Okay, and the cloud composer takes care of security updates, monitoring, and scaling Airflow environment setup, friends. So it will be taking care of that. So we have to focus only on writing the workflows. Okay. Yeah. Okay. So what can cloud composer do? So what the cloud composer it will be doing is first it is used for the automating 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 the data pipelines first. So it will be used for automating the data pipelines. First is the schedule ETL or ELT jobs. That means we can run the BigQuery queries, moving the data from the GCS to BigQuery and running the data flow pipelines, triggering the cloud functions. So these are the scheduling the ETL or ELT jobs first. So next is orchestrate machine learning workflows. So it's basically training the machine learning models regularly, evaluate and push models, and calling the vertex AI related jobs, friends. So basically, it's a machine learning related, friends. Okay. Then third is integrate multiple GCP services. The services like BigQuery, Google Cloud Storage, Cloud Run, Cloud SQL, Dataproc, PubSub. Okay. So then finally, fourth steps, friends. Manage the dependencies between the tasks. It will be running the task in sequence, parallel, or conditionally. Okay. Yeah. So next, we are going to see how it works. It's a simple view. We need to create a DAG file, which is nothing but Python code only. Because we are going to use it here in our lab. Also, we are going to do this same. Then we are going to upload that DAG file into our cloud composer. That is a DAG folder in GCS. It will be created first, and the composer runs it on Airflow. Like a composer, it will be managing on Airflow web user interface, scheduler, workers, and cloud logging environment scaling first. Okay. Okay. So why do companies use this cloud composer, friends? So we are going to see this few steps, friends. Basically, it's a fully managed, no Airflow maintenance. It is easy integration with all GCP services. Then this is reliable and scalable. Okay. Then finally, works for enterprise grade data pipelines. So these are the things, friends. Okay, when we should use this cloud composer? Basically, if we need to run the data pipeline like daily, weekly, monthly, then we can go with this cloud composer. And if we have some complex pipelines with dependencies, then we can go with this cloud composer first. Then this cloud composer, it will do some orchestrate multiple services like BigQuery, Dataflow, Cloud Run, and Cloud SQL. Okay. So you can go through these slide, friends. I will share these things to you. And one main, I could say, friends, in interview, they may ask, friends, what are the difference between the scheduler and cloud composer? Okay. So both are, it is scheduling, right? Then what is the use of the cloud composer? Maybe they may ask, friends. So these are the differences, friends. So cloud scheduler, basically, it's a cron job service. Okay. Cron job service. And it is very simple and a single step task execution, friends. But the cloud composer, it is a workflow orchestration service. It is running the complex data pipeline with multiple steps, friends. Okay, with multiple steps. That is the main, I could say, the advantage. Okay, then this is cloud composer. This is designed for ETL related, data engineering, ML related pipelines, friends. Okay, then this cloud scheduler basically it's a trigger used to trigger something at a specific time. Okay, so we have seen the cloud scheduler in our previous video, friends. You can go and watch that video also. Okay, I'm doing the data engineering related stuff, friends. Okay, now we are going to start the demo. Okay, we are going to start the demo. Now I am going to create a cloud composer environment. Just click create, friends. So this is the cloud composer. Just I'm going to open the composer. So this is the cloud composer. Managed workflow orchestration service. So here you can click create environment. I'm going to select this three, friends, because this is a low cost only. That is what I'm selecting it, friends. Here we need to give the name, friends. I am giving a test compressor. Then need to select the location, your central one. This is a low cost I'm selecting. And image version, I'm selecting as this 2.9.3. Then service account, friends. The service account, I'm going to select this compressor weather service account, friends. Okay. Then here I will talk about the service account, friends. Okay. What are the roles we need to add? Okay. I will tell you. Okay. Then resilience mode, we need to select this standard resilience first. So if you are selecting this high resilience unnecessarily, they will charge more first. That is what I'm selecting the standard resilience zonal availability, right? So then environment resources also I'm going to select small only, friends. Let it be, and I'm going to create it first. This cloud composer environment. So basically, the cloud composer environment, it will be taking some time first. So I think more than 15 minutes it will take first. Okay, so you have to wait for that. So you can see this creation time, right? 11:27 p.m. So basically, it will be taking more than 15 to 20 minutes first. So you need to wait for that. Okay. So here you can see, friends, in the cloud storage, the bucket will be created first. After creating the same environment, where we will be seeing it. Okay. Then I have to say about the IAM first. Okay. So few things I need to cover it. Okay. Let me go to the IAM. So what are the service account roles we have to add it? Okay. So how to create a service account? I have told a lot of times, friends. So this is the service account we need to use it first. So composer. Okay. So this is the one we need to use it first. So BigQuery admin, Cloud Composer, V2 API Service Agent extension, and Composer Worker, Data Flow Developer, and Storage admin. So these are the roles we need to add it first. Okay, we have to create it. Okay, so let me add this screenshot also so that it will be good. Slide deck. How to create a service account? If you don't know, you can go and watch my previous videos, friends. I have included. Okay, so I told also how to create this. It's a simple, not a big deal. Okay, so these are the roles we need to add, and it will take 10 to 15 minutes. Friends, I'm going to pass my video. Yeah, friends, but still it is loading, friends. So before that, what I'm going to do, I'm going to explain about the code, friends. Okay, so I'm going to explain about the code. So what I'm planning next video, we are going to cover it friends. Okay, let me explain about the code. Okay, then we will cover in our part 2 video friends. Okay. Okay, so we are going to see this DAG. Okay, so it's a weather pipeline, right? Data. So we have some DAG. We have to do five things, friends. Okay, first we have to create the GCS bucket only if not exist. Okay, so create bucket. So we have to create the bucket. So that is what this is the bucket name, friends. Weather data bucket hyphen ps. Then we are using this create underscore bucket. We are using this create underscore bucket, friends. Create underscore bucket. Okay. Okay. So we see here, we are using it here. Create bucket, TCS create bucket. This is for creating the weather data bucket use. Then it is saved to run if the bucket already exists. This ensures our pipeline won't fail due to the missing bucket. So that is what the thing is first. Then second step, fetched weather. Fetch weather Python operator. So this one, it will be fetching the weather data from the API. It is calling the Open-Meteo API, and second saves the weather JSON responses in a temporary local file, stores two values in XCOM, weather file, full temp file path, weather file name only. Uh, then third is upload to GCS friends. So upload to GCS book. Okay, so upload to GCS footprints. So that one basically it will be uploading the temp JSON file to your GCS bucket. Stores it as weather data bucket, US weather data. Timestamp it will create first. Okay. Then final part is this one. Generate the SQL, BigQuery load SQL. So this task creates the SQL first. So generate the BQ load jobs. So generate the BQ load jobs. So we are going to see this first. Okay. So generating the BQ load jobs. So loading the data from the project dataset table from the files. Then finally, we are going to see the load JSON to the BigQuery. BigQuery insert the job operator first. Okay. So this one, it is pulling the SQL from the previous task. Then loading the JSON data into BigQuery. Uses write upon mode. Okay. Use write upon mode default. So no new rows add every. So basically, it will be creating the bucket first. First step, okay. It will be creating the bucket and fetching the weather data. Fetching the weather data. Then next, uploading to the GCS first. Uploading to the GCS. Then generating to the BQ load job. Finally, loading to the BQ first. So that is what the thing is first. So here you can see query, load data, project data set table. So here we will be specifying this parameter first. So project ID, we have to give our project ID. I'm giving my project ID. So you have to give your project ID. Likewise, BQ dataset. So this weather dataset, we have to create it manually friends. Okay. In BigQuery, we have to create. BQ table, no need to create. It will be created automatically. Then this bucket name, weather data bucket used. This one also no need to worry. We need to give the unique bucket name first here. Then location is used. So in simple words, I could say friends, our DAG, what it will do means it will be make sure the bucket exists. Okay, so it will be creating the bucket and calls the weather API and saves the data, uploads to the GCS and loads it into the BigQuery. So that is what the goal, friends. So now I have explained about the code. Okay, in our next part 2 video, we are going to run the code. Okay, friends, let me in this video, friends. So if you have not subscribed my YouTube channel, please subscribe my YouTube channel so that it will motivate me to upload more videos about the Google Cloud platform. Thanks a lot. Have a great day. Bye bye.